Welcome to episode number 18 of Demystifying AI. Today, we're going to have a short dive in, first time into some of the regulatory issues around AI. I've been fortunate to participate in the Canadian Chamber of Commerce related to things AI, working with the government to start to introduce regulatory frameworks. And I think I'll talk more in detail about this in other talks, but I wanted to share some initial thoughts about how to regulate AI in the industry and protect society, businesses, people from any potential detrimental effects that obviously we're all concerned about and we hear about in the media all the time. So if I was to break the topic into three areas, one would be, first of all, if we're going to measure the harmful effects of AI on any given process, an industry, system, I think we need to first understand baseline performance. So how do things work today? So obviously we could say if AI was detrimental, you'd say detrimental with respect to what? So I think this forces us to have a better understanding of how things work today. So if we're in the medical system, for example, using AI to do MRI, read MRIs and make recommendations, then we need to have a good understanding of what the performance of that is today and what the impact on human life is from the current system. So we'd have that data, and I'm pretty sure in the case of the medical system, we would have a sense of how things are working today to see, does AI improve the healthcare system or does it harm the healthcare system? So first step, I think, is understanding in everywhere we plan to apply AI, everywhere we have a concern about how it might work, we should really measure and understand and set a baseline performance. That's step number one. I think in future talks, maybe we'll spend more time on that topic, on how to measure the performance of systems and business processes and industries. That would be the first area. I think the second area would be the practitioners. So the people who do data science and AI today, I think we need to take a look back at some professions like the engineering profession, where people in that profession, you go to school, you get a professional education, and then if you want to work as an engineer, the term engineer used to have a much stronger meaning, and you would have to get a professional engineering designation. So the Association of Professional Engineers in Canada, we have provincial associations. So I know I went to engineering school, and to get a license to work as a professional engineer, you would need to get a license. So you would have to take a course that was provided by the APO, which kind of covered law and ethics, morality, things like that related to the profession. And you had to pass that course to get a professional engineering designation. And then on top of that, you had to work as an engineer under the mentorship of a senior engineer who was already licensed. So it's a certain number of hours you had. And this was the protection of you had a degree from a certified educational institution saying you passed the certification and had the technical requirements to do the job. You took legal, ethical training on what those issues are in the profession of engineering, and you had to have practical experience working for someone who was already licensed. And then as you did your work as an engineer, if you were a civil engineer and you designed a bridge, ultimately the senior engineer would have to put his or her stamp on the final design, stamping that they have applied all the standard and best engineering practices in this design. And if for some reason that bridge failed, that engineer could potentially be liable for damages caused by failing to apply practices, assuming that the bridge would have collapsed or broken because there was some deficiency in the design or construction. And so these were safeguards in place to ensure that engineers didn't cause harm to society in the work they were doing. And so if we use that potentially as a model for AI, should you as an AI practitioner, should we have a more formalized education? I think right now, a lot of people can get into the job without any specific educational requirements. There's many career paths into data scientists. There's not necessarily a STEM education required. Many or perhaps most of the practitioners have some type of STEM education, but some don't. Some are self-learned, and there's varying degrees of STEM education that people might have. So I thought one way to regulate and protect society is to make sure that the people who are practitioners have the right educational background. And so we need to define what is the educational background that we would make practitioners go through, have a degree or a certificate or something to evidence. Then second step, should there be a body like the Association of Professional Engineers, and maybe this is something we can have a software engineer designation, which I know I haven't been keeping abreast of what the Association of Professional Engineers, but software engineer was not a discipline that was covered by the engineers in the past. But maybe this is an opportunity to, maybe the APO is a good governing body to bring back that designation to say you're a software engineer or a data science engineer or an AI engineer of some sort. They can own the education around the legal and ethical issues that are part of the profession that all the practitioners need to adhere to. And I think finally, if you're the one building a new model, and that could cause harm, it could cause bias, make biased decisions, cause harm to consumers, cause harm to medical patients, then the idea of stamping, putting your personal approval that I'm a registered practitioner, I have gotten experience under the mentorship of another professional practitioner, I have done the legal and ethical training, I have a university degree or a college degree that has been deemed as necessary background to practice, and I certify with my stamp or some digital certificate that says I stand behind this model, and if there's any liability or damages created by this model, then I am liable for those. And so there's some ideas maybe way out of the box or radical, but I think that's how we protected society from things like engineering and building of bridges and factories and airplanes and locomotives. I think those systems could have done severe damage over the years, and we've had many deaths and bridge collapses and plane crashes and failures of design. People were held liable. So I think if the same kind of risk to society exists from AI, then I think we should hold the practitioners accountable, and as well as then by definition, a company that hires engineers or AI practitioners would also be in that liability chain, that if your practitioners aren't applying best practices and standing behind their work, then corporations can be held liable for damage as well. So I think this is one second pillar of regulation, is to regulate the practitioners. And I think finally, the third pillar of regulatory would be the technology. How do we ensure that the technology does not make bad decisions? If you think of a steel manufacturing plant and there's a process, melting steel, making steel bars, there's a system where we have temperature and pressure and fluid flow and different measurements we can make of the system. A factory or plant typically will measure those, will measure the system performance and ensure that all the parameters of the system stay within expected statistical bounds. We call this statistical process control, that there is an upper control limit and a lower control limit for any metric. Maybe it's the temperature of the system, that if the temperature goes above a certain amount or below a certain amount, then we need to shut the system down gracefully, because being an outlier or out of ordinary operational ranges means the system could fail and there could be a catastrophic failure of the system. So we have in manufacturing plants and many systems, aircraft, engines, factories, nuclear power plants, steel plants, electricity generation, all of these things have control systems where they're being monitored with statistical process control for normal operation. So I think with AI systems, we have similar metrics we could be monitoring, like the data coming in. If you're building models off a data set coming into your system, did the number of records that came in this week, is that a normal amount? Or do we get too many records or too few records, indicating that something was missing? And any models we might build with bad data could be bad models, which could cause bad decisions, which could cause failure. So statistical process control on all the elements of the AI system, right from data coming in to the parameters in the model. If you're building a deep learning model and has model weights inside that, tracking the model weights from one record coming into the system to the next, we should not see a wild variation in model weights. So again, we have upper and lower statistical bounds on what these weights should be. And if those weights go out of range, then we think the model is going to misbehave and we don't trust it. The idea of statistical process control on every metric in the system, and there could be millions or billions of metrics, but we could monitor them all. We may identify which metrics have the biggest impact or correlation to the final output or decision we make, and we may monitor a subset of those. But I think the idea of applying statistical process control to make sure that the system or the model is behaving as we expect it to behave. And from one day to the next, as we get new data or apply the model again, we shouldn't see dramatic changes in any of these parameters that come in. And if the parameters are out of range, we should either shut the model down and go back and evaluate, or revert back to the last known good value. So if we knew that a certain parameter had a value of X, and all of a sudden it went out of range and the parameter was 2X, maybe it's okay to correct the parameter back to X, since that's right in the middle of that's the average value. And so that's a safety decision that we can always go back to the last known safe answer. Or if a decision we made was an outlier decision, then maybe we could dial the decision back. Like, let's say in retail, we're recommending a price point and we had never seen that price point before. This was like 50% out of range of any price that we've seen before. Maybe it'd be safer to correct it back within a certain tolerance of the range we've done in the past. So that's the third pillar: statistical process control, or technical guardrails that we can put on the system to protect. And I think we can regulate those types of things. Does the system make the same decision twice in a row? Some systems are non-deterministic and have a element of randomness in it. And so if you ran the system twice, would it come up with the same answer twice? And another element of that technical view that we need to say that if we ran the system and 100 decisions, ran a Monte Carlo simulation around the model training and model application, what is the answer? If we get 100 different answers, that would lead us to have very little confidence in the output of the model. If we got the same answer 98 times, then we could pretty be certain and that would be the recommended decision. So using this kind of statistical process control framework, and I think should be regulated, guardrails on the system. We should not be applying the system to data that it has never seen before. Just like if a child learns to take a step the first time, take one step down a stair, the child doesn't then go jump off a cliff thinking it can fly. The child will learn to take one step, then it does 2 steps and 3 steps. In the same way, we should have guardrails on a model to say that this model only works in this limited range of applicability. And if the data is outside of that, the model doesn't really apply. So guardrails to control the domain of applicability of the model or the system. And I think a lot of technology out there has no guardrails. So we start to believe a data point that is way out of normal range, we cannot believe the model. But I think today, because there's no guardrails on it, we believe what the model says. And we've seen lots of examples of earlier versions of chatbots that started swearing and saying all kinds of nasty things where there were no guardrails on the system, and the system was fed questions or data that was way out of its normal range. So those are the 3 pillars. First would be understanding what the baseline performance is, so we can measure, is this having a good effect or a bad effect? Regulating people and the certifying and training them and making them stand behind the work they do, stamping it, holding them liable for damages, I think would really constrain the pace of which we have released technology. And then finally, putting in technology guardrails like we have in engineering, statistical process control, doing fault tolerant type systems where we can apply fault tolerance algorithms, or when the system is non-deterministic, Monte Carlo methods, to make sure that we get the same answer significant enough time that we feel confident. So that's the topic for today. Hopefully that's an introduction to maybe some ideas and regulatory frameworks. And I've been fortunate enough to listen in on some of the conversations happening in Canada, and we'll share some ideas with the council that I'm working with to see if some of these ideas have merit or not. But as always, I welcome any questions, feedback, welcome guests on the show, as we'll start to look for folks to have discussions with to bring different viewpoints other than mine. But as always, subscribe on Spotify or YouTube, and look forward to hearing from you again. Thanks so much.